Council would like to welcome everyone in the first teaching session on bit manipulation. I would like to thank Aansh Sir for devoting his precious time and listening to our request to be a speaker and enlighten us on this particular topic. So, without taking much time, I would like to request Aansh Sir to initiate this teaching session. Um,
Hello. Yeah, Hardik, am I audible?
yes, sir.
So, okay, I'm turning on my camera also.
Sure,
I'm
sir.
sharing my screen. So, a basic introduction about myself. I am in third year of NSIT and I have been selected as an intern in Goldman Sachs. So, basically, this session is about teaching, and I have chosen the topic of bit manipulation. And I'll be uh, discussing some questions which have been asked in interviews of internships only, as most of the students are, I guess, in second year. Yes, am I correct, Hardik?
Yes, sir.
So, a formal introduction about me. I am in third year, as I've already told, and I've also been regionalist in ACM ICPC. I have means cleared the practice preliminary round with a rank of 196, and in last Google Kickstart I have scored 389 rank. And I guess I should start with session. So bit manipulation was very important topic for this. And my screen is visible.
Yes, sir.
Okay. So I want this session to be interactive. If you have any doubts, you can unmute yourself and ask the doubts as well. So the main reason why I choose bit manipulation was that most of the questions that were asked in interviews, like I also gave interview for Uber, and most of my friends gave for Microsoft and many other companies as well. Bit manipulation was a very heavily asked topic. Means everyone in now company was asking about questions that were based on bit manipulation. So starting with the main thing, like we have integer and Hardik, my screen is visible. Whiteboard.
Yes, sir.
Okay. So long we have three. I'll be talking about main three types. Long int. In C++ we have these int, long int. This was question actually asked in I don't remember the company, but they asked why we like we have 8 bytes in long int. Then how the number is stored in that 8 bytes? This was actually a theoretical question only, not the DSA one. So I'll explain first this one. And we have unsigned long int. I guess int is 2 bytes. Wait, let me confirm on Google only. Long int is 8 bytes. Yeah, int is 4 bytes. Long int is 8 bytes. So what it actually does is 8 bytes and 1 byte consider of 8 bits. So total we have 64 bits. Okay. So these 64 bits are a type of, let's say this is rectangle and we have 64 blocks in it. 1, 2, 3, 4, and continuing up to 64. So sorry. So the first one, this one, the first box is mainly determining the sign of the number. In the case of long int, in the case of int, like I'm talking about long int, it have 8 bytes and 8 bytes will be having 64 bits because 1 byte has 8 bits and 8 into 8 is equal to 64. So the first bit will determine whether the number is positive or negative. Rest of the 63 bits will be used to determine the number. So if we talk about the range, how it comes, like here it will be given the range. This was actually the question. So here the range of long int is from 923 dot 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 to minus 9233 to 9233. How it comes is 2 to the power 63 for the positive one and minus 2 to the power 63 for the negative one. This is the range, and we minus 1 because 0 is also included in it. So total there are 2 to the power 63 negative numbers and 2 to the power 63 positive and odd positive numbers, and 0 is also included in it. So range will be 0 to 2 to the power 63 minus 1, and here it will be minus 2 to the power 63 to minus 1. This will be the range. And if we calculate 2 to the power 63, I'll show it also. Wait, I'll print it over here. Actually, it will give runtime error because I'm doing it in long end. Yeah. So, okay, it is showing minus 922, and if I go to the range, this number minus 9233808, and it is same exactly as the output, which is 923, and at the end it is 808. So it is the range of long end. So the first number, if it will be 0, then it is telling that the number is positive. And if the first bit is 1, then it is showing that number is negative. So, uh, so what I actually wanted to tell is, okay, so what I actually wanted to tell is that long int consists of 64 bits, but actually 63 bits are being used to show the number, and 1 bit is being used to determine the sign of the number, whether it is positive or negative. So this is how we actually calculate the range. And if we come to integer part, it is 4-bit and 2 and total 4 bytes, and total bits will be, yes, if anyone can tell it, he can write in chat box. It's nothing, just we have to multiply it with 8 because 1 byte consists of 8 bits. Yeah, it's 32 bit. So 4 bytes will be equal to 32 bits, and out of 32 bits, 1 bit will be used to determine the sign, and rest 31 bit will be used to determine that number. And if I'll show you what is 1 power 31, 1 left shift 31, it comes to be 21474748368. And if I'll come here, it is same 648. Yeah, I told 2 to power 31 minus 1. So if I'll subtract 1, it will be similar to, it will be exactly same as this number 647. It is 648. So this is how we calculate the range. And if we come on unsigned long int, wait, I'll show you what actually in unsigned long int, this bit is also used to determine the number only. This bit is not used for determining the sign. So for unsigned long int, we have range from 0 to 2 to power uh, unsigned long int. It is of 8 bytes, and 8 bytes is equal to 64 bits. 2 to power 64 minus 1. So range for unsigned long int will be 0 to 2 to power 64 minus 1, which will be double of this number, which I'll show you. Yeah. which is exactly double of the previous number. 9 to, wait, I'll open in different tab only. As you can see, this is for long int and this is for unsigned long int. It is exactly the double of this number, 18446, and if we multiply this, it will also give 18446, and the previous number exactly same, 7 and 14 plus 1, 15, because it is from 0 to 2 to the power 64 minus 1. So what I actually wanted to tell is the unsigned long int and long int have same size, but their range is different, because in unsigned long int, the first bit, which I told in this rectangular box, which uh, tells you about the number, the first bit is not used for determining the sign in unsigned long int. Whereas in long int, the first bit was used to determine the sign. So its range does not include negative part, because everything in unsigned long int will be positive, and the size of the unsigned long int as well as long int are same. So if you have any doubts, you can ask in the comment section. Is that 7 because of 0? Can you please tell you are talking about which 7? The range of int. Yeah. So in negative, it is okay. I'll tell you once again. It is 4 bytes, and if I calculate in bits, it will be 8 into 4, 32 bits, because 1 byte is equal to 8 bits. Okay. So and 32 in 32 bits, 2 to the power 31 number will be negative numbers, which are from minus 2 to the power 31 to minus 1, and 2 to the power 31 I'm sorry, first bit is for determining the sign, and rest 2 to the power 30 numbers will be negative, and 2 to the power 30 numbers will be positive, which will be considered from 0 to 2 to the power 30 minus 1. So in negative, the last number was minus 2 to the power 30, and in positive, the last number was 2 to the power 30 minus 1. So that's minus 1 is because of, yeah, 0. So here it is 648, and here is 647. And I told 2 to the power 30 because, oh, sorry, 2 to the power 31, 30 only, because one bit is being used to determine the size of the sign of the number. If it's 0, it's positive, it's 1, it's negative. Yeah, is it fine? So coming on the first question, which is very frequently asked in bit manipulation, is to find the missing number. I'll tell you the question. Like, you are given a, it can be solved using the mathematical formula also, and bit manipulation. First of all, I'll tell you the question. The question is, you are given an array which consists of numbers from 1 to n, and a single number is missing. Let's say if I give you example, I have an array consisting of 4 numbers from 1 to 5, 1 to n plus 1, array with n numbers consisting from 1 to n plus 1. And I'm telling that from 1 to 5, a single number is missing. Let's say arrays 1, 2, 4, and 5. So in this, can you please tell which is the missing number? I have told that array should consist numbers from 1 to 5, and only 4 numbers are present. if you can tell, like 1 to 5, there are five numbers: 1 comma 2 comma 3 comma 4 and 5, and I have given an array of 1 2 4 5. You have to tell which number is missing. Yeah, correctly, absolutely correctly, it is 3. So you have to tell that 3 is missing. So what you can do is, first of all, if I'll tell you, so the most brute force solution, like in interviews, what you have to start with, first tell the most brute force solution, which is the most uh, ineffective one. So what you can do is, you can run a loop from 1 to n. This is the most ineffective one, 1 to n, and second from 1 to n plus 1, and second loop inside will be 1 to n, and check that from 1 to n plus 1 whether that number is present or not. If that number is not present here, do can is equal to 0. If arri equals to num, then can is equal to 1. If, like what I'm saying is, start with 1, traverse this whole array and see if that 1 is present or not. If you find that 1, it's good. Then check for 2, 2 is found, good. Then for 3, the whole array is traversed, you didn't find 3, so what you'll do, return 3. This is the most ineffective solution. This will work in n square. So what you have to do in interviews, you have to firstly tell the most ineffective solution. So this solution was most ineffective, it was totally brute force with n square time complexity. Yeah, that I told in beginning, that this question can be solved with two ways. Firstly, with the mathematical formula, and secondly with the bit manipulation. So this was the most ineffective n square. Now I'll come on a most effective solution, and we have two most effective solution. Firstly, I'll be talking about mathematical formula. So what you can do is, we have numbers from 1 to n plus 1. What you do is sum all the numbers, and its sum will be uh, n plus 1 into n plus 2 divided by 2. Why I did? Because the sum for 1 to n is n into n plus 1 divided by 2. 1 to n, this formula is n into n plus 1 divided by 2. So the formula from 1 to n plus 1 will be substituting n by n plus 1. So this will change into n plus 1, and this will be changed to n plus 2, and subtracting the sum of whole array. Okay. So the question was 1, 2, 4, 5, and okay, sorry. And we had numbers from 1 to 5. So the sum from 1 to 5 will be 6 into 7 divided by 2. It is equal to 21. 1, 2, 3, 4, 5. Am I correct? 9, 10, 11, 12, 13, 15. Sorry, it's 15. Yeah. Okay. I substituted 5 over here. It's 1 to 4 plus 1. If I'll substitute 4, 5 into 6 divided by 2, 30 divided by 2, 15. Yeah. So 15 will be the answer. And if I'll sum this, it will be 9, 10, 11, 12. 12. And what was the solution? It was here n plus 1 into n plus 2 divided by 2 minus sum of whole array. If I'll subtract 12 from 15, the answer will be 3. Correct? So that was the mathematical formula. But most of the interviewers find this formula very easy. Means they are looking for something different. So what we have to do in such type of question, we have to think in the think this question in the form of bit manipulation question. Like if the number are 1, 2, 3, 4, 5, and given array is 1, 2, 4, 5. Firstly, I'll tell you the property about bits, and we'll be using the property of XOR. And the XOR property tells that if we XOR two numbers, it XOR will be equal to 0. I guess most of the students will be remembering this formula, as this formula was in class 12th also. If you don't know, you can tell, I can prove it. Okay, so I'll prove it how it is done. So what is XOR? XOR means if we have two binary numbers, let's say 1011, and another number is 0111. So if we XOR both of these numbers, if both the bits are same, then the result is equal to 0. And if both the bits are opposite, then their XOR is equal to 1. So if we'll XOR this number, 1 XOR 1 will be equal to 0. I'll put here 0. Yeah, the number is 0101, because all the combinations will be combined: 1110 01 00. Okay, that will be nice. All the combinations are here in this question. So 11, both the bits are same. So answer is 010, both the bits are opposite. So answer is 101, both the opposite. So 1, and both the bits are same. So again 0. So this is the property of XOR. So how I am telling that A XOR A is equal to 0? Let's say A represent 11010, and again if I'll XOR with it, so all the bits are same. So I'm using this property. Both the bits are same. So every number will become 0. So this was the property that I'm going to use in this question. What I'll do is, let's say we have 5 numbers, and if I'll XOR it, it will become equal to, let's call this as A1, A2, A3, A4, A5. Again, another property that A XOR B is equal to B XOR A. And yeah, that's fine. And A XOR B XOR C is equal to B XOR A XOR C. So it is distributive as well as associative. So these are the 5 numbers, and in array we are given B1, B2, B3, B4. So if I'll XOR all these numbers of the array, and I'll XOR all the numbers from 1 to n plus 1, I'll get two numbers. This will be equal, let's say A1 XOR A2 XOR A3 XOR A4 XOR A5 is equal to, sorry, constant K1, and B1 XOR B2, B1 XOR B2 XOR B3 XOR B4 will be equal to K2. And if what I'll do is K1 XOR K2, it is having n plus 1 numbers, it is having n numbers. And if I'll draw the Venn diagram, these are the n plus 1 numbers that we wanted to have in the array. And these are the n numbers which are the proper subset of those n plus 1 numbers. This is the array. And these were the numbers that we should have. These are n numbers. So if I'll XOR this outer one with the inside one, all the n numbers will be cancelled by n numbers that were inside it. So at last we'll be left with only one number that was not present in this array. So what I wanted to tell is, if I'll XOR A1, XOR A2, XOR A3, XOR A4, XOR A5 with B1, B2, B3, B4, we'll get the last number which was not present. So if I'll show 1 XOR 2 XOR 3 XOR 4 XOR 5, then I'll XOR with 1, the 1 and 1 will be cancelled. Then I'm again XORing with 2, then this 2 and this 2 will be cancelled. And if I'll XOR with 4, this 4 and this 4 will be cancelled. And if I'll XOR with 5, this 5 and this 5 will cancel. and the remaining number will be 3. That should be the answer. So this was a very basic question of bit manipulation, and we used the property of XOR for solving this number. I hope everyone are clear. Yes. If you're clear, you can tell in chat. Oh, yeah. So this was asked most frequently in Microsoft because they, yeah, it's basic question. So this was question was is asked in many companies. Now, if I tell you, this was about finding the missing number. The previous question was finding the missing number. Now I'll tell you a question about finding the duplicate number in the array. Let's say the array is having numbers in pair and a single number is present only once. Let's say an array is having AA, BB, CC, DD, and the single number that's present in the array is F. Now, if I tell you that find the number which is not having any duplicate in this array, and I'm assuring you that all the numbers, rest of the numbers which are present, are in pairs. What I want to tell is by looking at this example, we can say AA is present in pair, BB is present in pair, CC present in pair, DD present in pair, and you have to tell the number which is not present in pair. So can anyone tell how you approach this question?
वेल बेसिकली तो सर हम इसका सारा एक मैप में डाटा डाल सकते हैं और फिर चेक कर सकते हैं किसका अकरेंस 1 या 2 है.
Yeah, that's the correct solution. What I can do is I'll make a map, and for A there are two numbers, B there are two numbers, C there are two, D there are two, and for F it is only a single number. Then I'll return the answer 1. Then what mostly the interviewers will say that can you optimize it for like it is having O of n space complexity, and even the time complexity is O of log n for searching because we are using hash map. Can you tell? Yeah, it's correct, Hardik. Yes. So that solution was also correct, and this solution is also correct. What I am going to do with XOR property once again. But the difference is it was using O(n) space complexity and O of log n time complexity. Now I'll tell you why O of log n, because hash map does not always work in O of 1. It uses the searching time complexity in O of log n. So the best solution will be using XOR property. So what I told you previously, that XOR property tells that if two bits are same, then result will be 0, and if two bits are different, then result can be anything. If two bits are different, then result will be 1. Now what I tell you, if two numbers are same, then again result will be 0. I'll tell you the number is this, and again the XORing it with the same number, its result will be 0. And if two numbers are not same, then it is not guaranteed that answer will be 1. It is to be founded with the XOR property only. Like I say, our first number is 2 and another number is 3. So 1. The first number is 2 and another number is 1. So XOR of both of these number will be 3, because XOR of this will be 1, XOR of this will be 1. So this is equal to 3. So this will be dependent. So again, coming to the question, what I wanted to say is, let's say this is in sorted order. If I write in any format, A, comma, B, comma, A, comma, C, comma, D, comma, C, comma, F, comma, D. So what I'll tell is the first A XOR B will give some number that is dependent on A and B. Then, okay, I'll write it here. A, then XOR B. It will be dependent on both of these numbers. and again the A is coming, so it will cancel out with this one because the XOR property was distributive. What I can say is it is like A XOR A cancelled XOR B. Okay, so C is coming, it will make A XOR B XOR C. And then again B was coming. B will be cancelled with this one, which was already present in the temporary XOR. This is temporary XOR we are doing so with this from the starting. Then C is coming, it will cancel C. So up till here, the XOR of this array will be 0 because this A is cancelled by this A, this B is cancelled by this B, and this C is cancelled by this D. Now coming on these three number, I'll XOR, it became 0, then again XOR with D, this number, the temporary will become D, then F will be coming, it will become D XOR F, then again D will be coming, it will be cancelling this D. So finally the leftover number is D and that will be answer. And I have also proved that answer was F. So XOR property is also used to calculate the number which is having no duplicate pair in the array. And the brute force was this one using map, and for saving the time complexity as well as space complexity, the XOR which comes under the bit manipulation topic is used for this. So is it fine? Okay. So now I'll be telling about a question that is using XOR property for saving the space complexity. This question was again asked in Microsoft only. Okay. So you are given two numbers, A comma B. Now I want you to swap the values of B in A and A in B. Let's say A is equal to 5, B is equal to 9. I want you to swap these numbers such that B becomes 5 and A becomes 9. Can anyone tell how you'll approach this question? If anyone can, he can unmute or yeah, A is equal to A plus B, B is equal to A minus B, and A will be again equal to
A equal to A minus B again.
yeah. So this question can be solved in two ways again. Uh, Firstly, brute force. What you can do is you can make a temporary variable C and first store C is equal to A, then make A equals to B, then make B equals to C. This is the most brute force solution, which is using an X. It will be equal to B. I understand it was hard to understand. I'll explain it again. That all the plus and minus in this formula will be converted into XOR. And firstly, I'll change A with A XOR B. Okay, and then I have to find B. And I already told you that something XOR with something equals to 0, then these both numbers should be equal. And A was now consisting of A XOR B. And if I'll XOR it with B, then B will change into A. Okay. So B was swapped into A by XORing A. Like I can say that B is equal to A XOR B XOR B. It is equal to A. And this A XOR B was done in above step. A is equal to A XOR B. So B was converted into A. Now if I'll come in A, which was A XOR B, I only have to XOR it with A, then it will convert into B. And I know that the value of B has been changed into A, so I'll XOR it with this value and the answer will be B. I hope you have understand. If you want, I can write down the code. It is pretty simple. Like So it was so simple that A is equal to A XOR B, C out A, B. Okay. If I put the input at 5 and 9, now A was 5, B is 9. The answer should be 9 and 5. Let's see what the answer will be. 9 and 5. So it is swap 5, 9, 9, 5. It is so simple that you have to do nothing. Write 3 ABA and in each step you have to do A XOR B, A XOR B, A XOR B. The answer will be solved. I hope. Isn't it? Yeah. The space complexity is exactly same, but what this solution is unique. Like we are using bit manipulation for swapping the two numbers, and even the formula is simple: A XOR B, A XOR B, A XOR B. Like you can see over here. Okay, I'll what I did was A is equal to A XOR B, B is equal to A XOR B, A is equal to A XOR B, and the finally answer was swapped. And space complexity is exactly same. You can do in both the ways, but if you show that I know mathematical solution also as well as XOR bit manipulation solution also, then it will be great. Okay, so these all questions were even present on Geeks for Geeks. I found a very unique question that was asked in previous month only, and that question was: you are given a number. I like this question very much. So you are given a number, and the number is consisting of bits alternatively flipped. Like if I give you a number 101010, so you have to say this number yes, because 10 these are alternately flipped, like 101010, and or another example 01010, this also yes. But if I 110001, no, 110101, again no, because these two numbers are not alternatively flipped again. So can you tell a way how you can solve this? If anyone, yeah, you can unmute your mic and even tell also. Like if you want to try, you can unmute your mic and we can have some brainstorming on this question. Anyone? Okay. So I understand this question was pretty difficult also. So this was the question, like 101010. Now what you have to do is tell if these numbers are alternately flipped or not. So what way will you be using? Can anyone tell?
So,
Yeah.
so we are given one and zeros, like of a number, or like,
Sorry. Yeah, this is bit representation of a number.
okay, so what I can tell, from my approach is like we can store like the bit representation of a number like in an array.
Okay.
It will take this solution will take will take a lot of space, but like we can store the bit representation in an array. Then then we can like for reference we can take the length of the array as in.
Okay. And
And
yeah,
after
I
that, sir,
understand.
alternatively, sir, like if there is one and zero, like alternatively, sir, we will use XOR on alternate numbers. And then if we are getting one on doing
Okay.
XOR or alternative numbers, then we will do like count plus plus,
Okay.
and this will go till the end. And as our code comes to an end, we will check if count is equals to n minus one.
Okay.
And
Like in
if
this
it's
number.
n minus one, then we can print yes. And if it's like less than like n minus one, the count value is less than n minus one, then we will print no.
Okay. What you
I,
are telling is like use
I would
this.
have liked it done in a slightly different way. Like I would have used like two pointers, one at zero and other at next, and do a pairwise XOR. If it shows 0, then we can just say no.
Can you repeat once again?
लाइक मैं 2 पॉइंटर्स लेना चाहूँगा, एक लाइक 1 पर है, एक उससे अगले वाले बिट पर है।
Okay.
इनका एक्सऑर कर दिया। अगर यहाँ पे कहीं भी मेरे पास 0 आ जाता है तो मैं डायरेक्टली नो कर सकता हूँ फिर उसको, कि लाइक वो नहीं
So
होगा।
yeah, I guess this approach was exactly similar to previous one. Let me check. 1 0. It's 1 1 1.
एंड वी कैन स्टोर
Okay.
इट इन अ स्ट्रिंग, लाइक अरे में ज़्यादा ही स्पेस लगेगा।
Yeah, you can do 1 minus character 0. It will only make a factor of 4 because character takes 1 bit and integer takes 4 bit. Yeah, it's correct. And the previous one was also correct. Like if we'll check this two pair, this pair, then this pair, then this pair, then this pair, and at last this pair. These are total 1, 2, 3, 4, 5, and we are having total 6 number. Yeah, that's both the approaches are correct, absolutely correct. But the space complexity for this is O of n. And if I'll tell you, can you please do this for me in O of 1 space complexity? I agree, this solution is absolutely correct. Both the solutions are absolutely correct. Like if I'll take 2 pointers here, I'll check it, then I'll take these
So
2 pointers.
so
Yeah,
while converting it into the like bit like into the bit representation, uh,
that's it.
सर जब हम नंबर को सर बिट फॉर्म में कन्वर्ट कर रहे होंगे सर लूप करके
Yeah,
सर तो हम लाइक कंटिन्यूसली सर हम आगे लाइक दी प्रीवियस नंबर एंड दी अपकमिंग नंबर को सर हमें एग्जॉर करेंगे
okay.
and sir like someone was saying like it's like from his approach only like sir अगर वहां पर हमारा जीरो आ गया एग्जॉर के बाद तो हम वहीं पर ही लूप को ब्रेक करके लाइक नो प्रिंट करा देंगे
Can you repeat once again? Like the number is 101010. What you'll
यस
do?
सर सर हम सर हम लूप के अंदर सर एक लाइक बिट रिप्रेजेंटेशन सर हम लाइक बिट्स निकाल रहे हैं एंड सर लाइक
Okay.
सर प्रीवियस द प्रीवियस वन एंड दिन अपकमिंग जो सर हमारा बिट आ रहा है सर हम उन दोनों का एग्जॉर कर रहे हैं एंड सर अगर एग्जॉर करके सर जीरो आ गया तो हम ब्रेक करके सर लाइक लाइक नो प्रिंट करा देंगे एंड सर अगर हमारा लाइक लाइक लूप लास्ट तक चला तो सर हम आंसर
Mm.
यस कर सकते हैं तो सर इसके अंदर
Yeah, that is correct. But again, the space complexity will more. Like this number is not given in the form of 1010. It
वन
will be given in the form of 1, 2, 4, 8, 16, 32. So the number is 32, 40, 42. 42 is the number. You have to tell is 42 is yes or no. And this number was 1, 2, 4, 8, 16. 16 plus 8, 24, 24, 25, 26. Like, yeah, we are having two number 26 and 42. You have to print yes in 42, but you have to print no in 26. Yeah. Yeah, you can absolutely use left shift or right shift. Left shift takes exactly O of 1 time complexity. What you are doing in left shift, you are multiplying by 2, or in right shift, you are dividing by 2. Yeah, this is the very important fact that if you are telling anyone that divide this number by 2 or multiply this number of 2, always use left shift or right shift. This creates a good impact of yourself that, yeah, you know something great about bit manipulation. Like, don't use multiply by 2 or divided by 2. This is the good way of practice. Someone was telling about right shift and left shift that he was getting very close to the answer. Like this is 1010. If I left shift it, the new number, okay, I'll write it over here. New number will become 101010 1. Oh, sorry, 0. So can anyone tell what now we can do? This was done in O of 1 only. It's very simple from here onwards. Can anyone tell? Like the number was 10, 10, 10, and the new number
XOR,
was
then right shift, then all of the bits are 1 if you
correct.
satisfy.
Absolutely correct. If I'll XOR it, it will 1, 1, 1, 1, 1, 1. Last bit will be 0. Then again, because we have left shifted it and then done XOR, we have to do again a right shift operator. So 1, 1, 1, 1, 1, 1. And check if all these numbers are 1 or not. How will you check if all these numbers are 1 or not? In a single move. What I did is, yeah, what I did is I was given the number 42. I left shifted it. And after left shifting, the number became 84. And what I did was I XORed 42 and 84. One thing which I want to make clear is these multiplication, division, XOR, and even OR and operation takes exactly O of one time complexity as well as O of one space complexity. So if I'm multiplying it with 2, this is done in O of 1. I'm XORing 84 and 42. It is again done in O of 1 only. Now I want to check if all the bits in these numbers are 1 or not. The very basic way will be divided by 2 and check modulus 2, then divide by 2, check modulus 2. Any other approach? Okay, it's very simple. Set how मतलब कैसे करोगे set को use? हाँ. But again, you are traversing this whole bit thing. Like for 84 XOR 42 bit, let me print what is 84 XOR 42. Forty-two was our first number. What I'm doing is A left shift one, sorry. So, okay. It is equal to 126. Let me check if the value of B is correct. Yeah, it's 4284 and XORing it will give 126. And 126 divided by 2 will be equal to 63. Okay, yeah, this number is also 63. If I'll confirm 1, 2, 4, 8, 16, 32. 32 plus 16, 48, 54, 58, 60, 60, 4, 5, 6, 7, 15, 31, 63. Okay, this number is 63. How will you check that if 63 is having all the bits set? Means all the bits are equal to 1. To I want to correct that this is exactly a number 63. This is not a string. Like yeah, I can get what you are telling that total 6, but this is the bit representation for this. Can you tell 63? Yeah, that you were very close. Like it is a similar question if I want to check if a number is a power of 2 or not. Anyone? Okay, I'll tell you. What I can do is 1 1 1 1 1. I'll let's say I have a number 64, which is equal to, I'll take a new question, and that question is based on this only. I hope you have done it. 1006. I want to tell if this number is a power of 2 or not. A number is a power of 2 if only one bit is set. Can you tell how will you be able to do this? Only a single bit is set. It is then power of 2.
सर
Like I
नेक्स्ट
can
शिफ्ट
show
करने
you.
पे जीरो हो जाएगा.
Yeah.
नेक्स्ट शिफ्ट
Next.
करने पे जीरो हो जाएगा नंबर.
लेफ्ट शिफ्ट
सिंगल लेफ्ट
करने
शिफ्ट
पे,
करने पे.
लेफ्ट शिफ्ट करने पे तो लेफ्ट शिफ्ट किससे करोगे? 1 से?
यस सर.
फिर तो वो 2 से मल्टीप्लाई हो जाएगा ना.
128 हो जाएगा.
हाँ, 64 को 2 से
हाँ
मल्टीप्लाई करेंगे 128 हो जाएगा. वो भी 2 की
हाँ
पावर है.
हाँ.
नहीं, सही जा रहे हो. कैसे करोगे? मैं क्वेश्चन दिखाता हूँ. ये भी काफी फ्रीक्वेंटली आस्क्ड क्वेश्चन है. ये देखो यही आ गया. चेक इफ अ नंबर इज अ पावर ऑफ 2. जैसे 2 की पावर 2. इफ n इज इक्वल टू 4, n इज इक्वल टू 7 पे नो, n इज इक्वल टू 32 पे यस. हाउ विल यू डू दिस?
हम चेक करेंगे कि उसमें ए के बिट सिर्फ 1 होएगी पूरे.
वो कैसे चेक करोगे ए की बिट 1 है या नहीं? जैसे इसमें ये दिया हुआ है 16, 15. ये भी ना काफी फ्रीक्वेंटली आस्क्ड क्वेश्चन है. इसमें क्या करते हैं ना, इस क्वेश्चन को ना इस क्वेश्चन पे हम चेंज कर देते हैं. व्हाट वी डू इज, एक मिनट मैं न्यू स्लाइड खोल लेता हूँ. वी हैड नंबर 11111 विच वाज इक्वल टू 63. ठीक है. और इसमें +1 किया तो ये बन गया 100000 विच इज इक्वल टू 64. अब इन दोनों नंबर को अगर मैं ऐड कर दूं तो इसका आंसर 0 आएगा. एग्री? Like if I'm having a number in which all the bits are set, means all the bits are equal to 1, and if I add a 1, it will be equal to a number which is a power of 2. Then all these numbers will become equal to 0, and the most significant bit will be equal to 1. Agree?
Yes, sir.
Okay. I'll give you a real example. Like if I'm having a number 3, this is equal to 3. If I'll add 1, what should be the answer? 4. And if I 1 plus 1 0, and here 1 1 1 1 plus 1 again 0, and here 1 and 1. So this is the representation of 4. If I uh, add a number in a number which is consisting of all the numbers equal to 1, then it will become a number which will be a power of 2. If I add a number 1 to a number having all the bits in its bit representation equal to 1, then it will become a number which is a power of 2. Again, taking example 7, 4, 5, 6, 7 plus 1, it will be 8, and 8 is 1000. Agree? Yes? Yeah. Yes. Atif is exactly correct. What I'll do is I'll add both of these number. And if I add both of these number, it is having 0111 and it is having 1000. And if I add both of these number, it will become to 0. What I want to do is and because the question was to check if the number is having all bits equal to 1, then I'll add that number with a number n plus 1, and that should be equal to 0. Only then the property will be satisfied. Like the number is 1. So the at the starting the question was that I am having a number in which alternative bits are opposite, like 101010. What I did was I left shifted this number and I XORed it. 101010 0. Then the result came to be 1 1 1 1 1 1 0, and then I again right shifted it. The result became 6 times ones, and I wanted to check if this number is having all bits equal to 1 or not. What I did was I add a 1, the number became 1, and 6 times 0, and I AND both of these number, and that result should be equal to 0. So this was the question which was asked. It was asked in one of the most reputed company, and this was the solution they wanted the student to give. So the firstly, the both the solution that were told by you all were correct, that we can keep two pointers and XOR it, or we can make pairs and XOR it. The total number of one should be n minus 1. Both the solutions were correct, but it were taking a time complexity of O of n. And this was the best solution, and it is taking a time complexity of O of 1. Okay, I can code it and show it to you. It is very simple to code. Like C in A, B is equal to 1 left shift A, then A is equal to A XOR B, then again A is equal to A right shift 1, and then A plus plus. No. Okay, for 42 we should have a yes. Let's see. It is showing yes. And if I take a number that is not with this property, let's have a number equals to 3, 1 1, and let's check. And it should give a no. Let us check if it's showing no or not. No. So the code is absolutely correct. It is a very short code. Just the understanding is bit difficult, but the code is quite short. What I did was I taken an input A, then I made a temporary number which is equal to left shift of 1 time A. Then I XORed it with A. I'll show it over here. 42 was the number. 101010. This is 42. I Let me open the code side by side. This was 42, and I left shifted it 1 time. So this number became 101010. Okay. Then what I did is I XORed these numbers. If I take XOR 1 1 1 1 1 0. What I did was I right shifted it once. This 0 will be cancelled. Then I added a 1 in it. The number was 6 times 1 plus 1. Then number will be 1, and then 6 times 0. This was A. This is 10. Then what I did was I and both of these number. If I land 0 0 0 0 0 0, and here it is 0, so 0. And if A and 10 equal to 0, then yes, else no. So this was the most difficult question which I think that was asked under the bit manipulation topic. So that's all for today. I hope you like the session. Hardik, is
Thanks a lot, sir.
this all going away? Yeah, I understand. This is a bit difficult topic for understand. Uh, but yes, the level of the question was this only that was asked. The first three questions were very basic, and What you also covered in this question is check if a number is a power of 2. Let's say I have a number 64 or 16 or 8 or 32. What you can do is subtract a number, then again, and let's say I have a number 1, 0, 0, 0, 0. I want to check if this is a power of 2 or not. A number is a power of 2 if only a single bit is set and all other rest are 0. A single bit is 1 and all rest are 0. So what I can do is I subtract 1 from it and it will become 0, 1, 1, 1, 1, 1. And if I take and, then result should be 0. That means n and n minus 1 should be equal to 0 for a number to be a power of 2. So this was also covered in this topic only, which was previous. The question was if I'm having this number in which all the bits are 1 except the first one is not to be considered. All the bits are 1 and we have to check if all the bits are 1 or not. What I did was I add 1 to it. It becomes n into n plus 1 and that should be equal to 0. So both of these questions are relatively same and these are the most frequently asked questions. So I hope you understand. Modulus, huh? What modulus of 2 equal to 0? That's not always correct if I'm having a number 6.
Actually, it's
If
an
I'll
even
model,
number,
yes,
which Hassan is saying. The thing he's saying, it's the condition for checking if it's if a number is even or odd.
yeah, that's I'm telling like,
Um,
yeah, that's correct. Let's
Hassan,
say,
but you are
but
dividing a number by only once. Like you are dividing a number by 2 only once. Like there can be many number. Like it's even. If like for say if we are taking a modulus by 4, then we are checking for the multiples of 4. They are also power of 2 only.
let's say number is 12, I'm modulus 4, then it is 0. But actually 12 is not a power of 2. Only the power of 2 are 1, 2, 4. And if I'm having 6, I'll modulo 2, then equal to 0. What I can do is, okay, let me show. If a number is n, it will take log n complexity. It is also fine, but that was best in O of 1. I'll show you how to do in O of log n. You'll understand this quite well. If I'm having a number n, and if I'll check if modulus 2 equal to 1 and n is not equal to 1, then return false. Else n divided by equal to 2. Let's say I have a number 6. I want to check is it giving remainder equal to 0 when I'm dividing by 2? Yes, because it is divided by 2. Then I'll convert this number into 3. Then I'm checking is this number giving me the remainder of 1 if I'm dividing it by 2? Yes, but this number is not 1. So I'll return false. Else I'll take another example 32. Is this number divisible by 2? Yes, divided by 2. Is this number divisible by 2? Yes, divided by 2. Is this number divisible by 2 divided by 2? Number divisible by 2 divided by 2. In the end, if I get number 1, then the starting number was guaranteed to be a power of 2. If I'm not getting 1, that starting number was not a power of 2. Let's say another example, I'm taking 10 divided by 2, 5. 5 is not divisible by 2 and 5 is not equal to 1. So 10 is not divisible by 2. So this whole step is taking log n time. Hassan, did you understand? Okay, I think the time has been ended for the session.
Thank you, sir, for such a beautiful session. I hope that
Thank you.
like you can keep such teaching sessions in future,
Thank
and
you.
all the
Thank you
best for
so
your
much.
future endeavors.
Thank you. Thank you so much. If anyone is having any kind of doubt, he can ask whether about college life or internship seasons or what to do in second year, what projects we have to make, any kind of doubts you can ask. Okay. Okay, so basically the projects are necessary for internship. What you can do is you have to make about two projects. The most easy topic will be web development. Like I made my project one on web development. It was chat application. Another project was based on DSA. It was a what I can tell is it was based on bit manipulation only. You put two numbers, it will tell if you put two statements, it will tell it is contingency or tautology or falsely. So these were the projects, and second project hardly took me 5 to 6 days because it was a part of our syllabus, our course only, and the chat application took me about 15 to 20 days. It was a group project. So what you can do is you can make your friends and all can make a group project, because what I see most of the friends are not going in same interview, and if even if they are going in same interview, the interview will not be same. So what you can do, you can make a group project and you can show in your interviews. So I guess WebD is the most easiest thing. And if you are going towards ML, that will be slightly tricky, and even the questions asked on the project will be slightly difficult because ML is having a lot of algorithms and mathematical work. So WebD will be fine. Any else doubt? So I guess Hardik, we should end the session. Hardik? To be honest, what mostly the interview is all about DSA. So project is having a very slight weightage. If you are having good DSA skills and if you are having exposure of competitive programming also, then projects will be of very less value. So means I won't say ML projects will be having an edge. Only a project is necessity, not the type or kind of project. Yeah, but it should be done by you. If they are having any counter question, you should be able to answer that. If you are not able to answer that, they'll straightly say on your face that have you copied it from GitHub or else. Means I have even seen some interviews, they tell it on your face, this project is from GitHub. So try to do project on your own. If you are taking from somewhere, then be sure that you are knowing each and every line of the project. But if your DSA skills are good, you can overcome this part of projects. Any else question? Okay, thank you. Hardik? Hardik, are you there?
Yes, sir.
So I think we should end the session. It's already 7:15.
Sure, sir.
Okay. So thank you so much. Thank you everyone. I hope we'll meet again. Okay, thank you.